Hello, me again. All right, here we go. We're going to finish this up. I have another example on finding the zeros of a polynomial function. Here it is. So this time we started actually with a function that is to the fourth, has a degree of 4. So again, we start by making f of x equal to 0. From here to here, what I did was actually divide both sides of this equation by -1, just so I could get rid of the negative here. It will make it easier when I'm factoring. But if we were looking at the end behavior of this graph, we would still want to consider what's going on in the original function. In fact, leading coefficient negative with an even degree of 4, this function, or the graph of this function, would actually fall left and right. Okay. However, for finding zeros, we can do this strategy so that it's easier to factor. So what I did first was take out the greatest common factor from all the terms, which is x squared. And then what was left over is actually factorable into x minus 2 squared. So we let x squared equal 0, we let x minus 2 equal 0, and we find out our zeros for this function are 0 and 2. Okay. The next thing that we need to talk about is something called multiplicity of zeros. So here are the notes for that. The multiplicity of the zeros has to do with how many times a factor occurs in a factored polynomial. So if we look at the last one that we just did, when we factored it out, it looks like this. And the factor of x occurs 2 times because x times x is x squared. So there are 2 factors of x there. Okay, so the zero that resulted from that factor has a multiplicity of 2 because it occurred 2 times. The same thing goes for the other one, which was x minus 2. It occurs 2 times because it was x minus 2 squared. So the polynomial has the zeros 0, multiplicity 2, and 2, multiplicity 2. Now, why is the multiplicity important? Well, again, remember that we're thinking about the graphs of polynomial functions at this point, and the multiplicity of the zeros has something to do with the graph. Here it is. Okay, the multiplicity tells us something about graphs. Number 1. If a zero has odd multiplicity, the graph will cross the x-axis at that point. But if the zero has even multiplicity, like the ones we just talked about, then the graph will touch but not cross the x-axis at that point. So let's put this all together in one example. We're going to look at a polynomial function. We're going to find the zeros of it. We're going to talk about the degree. We're going to talk about the end behavior, and then I'm actually going to draw a little tiny sketch of it. Well, it's already drawn. So here we are. We have this function. Oh, let's see. Let me get it straight in there. Here's the function. Over here is where I kind of started thinking about what was going on with this one. This one has a degree of 3. Again, because if I were to multiply this out, okay, by squaring this one, I would get an x squared term. An x squared term times another x would give me x cubed. So this one has a degree of 3. The leading coefficient in this case is positive because 1/2 is positive. So that tells me that this graph is going to fall left and rise right. Okay, so I had odd multiplicity with positive leading coefficient. Then to find the zeros, this one's interesting. We make f of x 0. But this one is already factored. Okay, so I don't have to do any factoring. So don't make these problems harder than they are. If they're already factored, that's fine. So all I needed to do was set each factor equal to 0. So x plus 1 equals 0, and 2x minus 3 equals 0. Okay, from this we get x is -1, or x is positive 3/2. Now you'll notice I've also listed their multiplicity. This one only occurred 1 time, so it has a multiplicity of 1. But this one has a multiplicity of 2 because it was a squared factor. Okay, what does that mean? Well, here's the graph. This is kind of helping you maybe put it together. We know that it's falling on the left. I put these dashed marks here because I don't really know for sure what's going on in there. There could be some crazy stuff going on, so I'm not for sure about that. However, I do know on the x-axis at -1, okay, that's a 0. that this graph is going to cross the x-axis because it has a multiplicity of 1, which is odd. Okay, it goes up. It has to turn around at some point. Now, I don't know where it turns around. Maybe it goes way up high and comes back down. Maybe it goes very low and comes back down. So again, that's why I used the dashed marks there. And it's going to come down, and now at positive 3/2 or positive 1.5, you'll notice, right, the multiplicity of that 0 was even. Okay, so the graph is going to touch the x-axis, but it does not cross over. So it's almost like it touches the x-axis and it bounces back the other direction. And that's what's happened here. Again, that this function is going to rise to the right. Again, I've got that kind of going on in here. I'm not for sure. So that's why I use those dashed marks. So as far as your assignment today, you won't be doing any graphing. But when I get back, we will be doing some graph sketching. And again, this is just a sketch. It's not anything. We don't know these points kind of in the middle. That's what we do in calculus. So that's just a little preview of next year for you. Okay, so my computer is lagging. I hope that you can still hear me. And okay, there I am now. That's all the notes that you are going to be doing an assignment from your book. You're going to be looking at functions and either, number one, determining if they are polynomial or not. You will be determining the degree of polynomial functions. You will be looking at end behavior and also finding the zero polynomial functions. So your assignment is on page 312. You're going to do 1 through 32 all. There it is. Okay. And that's all I have for you. So I hope that this was helpful, and I can't wait to be back with you next week. But now I'm going to go to the ocean. See you later. Bye.